Hi everyone, this is a video about the integration by of function, and here I have four example questions 7, 8, 9, 10. All questions, sample question, involve the function which I need to use substitution, okay, to integrate. So here to shows you the integration by substitution. Here I have a question 7a. Look at the question 7a. I have a 4 minus 5x power of 3. Integrate this function with respect to x. All right. So then now I'm going to, we can see that the power is a power of 3. And the question B, we have a power of -4 when we bring up. And here we have a power of 4. And the question D, we have a fraction power, which is 2/3. So those power for is just like the power of negative and power of fraction. We are not going to expand it. If we have a power of an integer, positive integer, the power is very high and it's so tedious for us to expand and integrate. So we are going to apply the substitution here to integrate. It will be much more easier. All right. So firstly, let's see how the substitution work. I will let u equals to 4 minus 5x. Let u equals to something that is inside the bracket which has the power. All right. Then after that, this one later on, this can be substituted as u, and the dx is going to substitute it in terms of du. Here I need to find the du dx. Du dx equals to -5. Later on, I can see that my dx here can be substituted as du over -5. Just bring this up, and the -5 bring it to the left hand, the other side. All right. Then after that, after I have enough sufficient information to substitute it to be substituted into my function, I can start to substitute. 4 minus 5x substituted as a u, and the power of 3 just copy down. Dx can be substituted as a du over -5. -5 over here is 1 over -5. I'm going to bring it out. It becomes our coefficient. All right. So here I have a -1/5 and integrate the u cubed with respect to u. Just write down the coefficient, -1/5. And we're going to integrate u cubed with respect to u. We have a u power of 4, increase the power by 1, and divided by 4. Because this is an indefinite integral, meaning that there is no upper limit and lower limit, we're going to plus constant c, and then we simplify our answer by substitute back the u as a 4 minus 5x in terms of x. Okay, so here I have a u as a 4 minus 5x and power of 4 divided by 5 multiplied by 4, you get 20. And final answer is this. This is the information I highlighted with the red line. Okay, this is all the information we need to substitute into the function. Let's look at the question B. This is the example B. Here, take out the 3. I will write the power of 4 I bring up, and it becomes a power of -4. And we're going to integrate this with respect to y. And we can see that we're not going to expand it because the power is negative. And now I will assume u as a 1 plus 2y. I will make this into the single term. Alright, originally it's 2 terms here. Now I make it into the single term later on, because once I substitute the u inside, I will have a u power of -4. And how am I going to substitute dy in terms of du? We're going to differentiate the du with respect to y. Find the du dy. You have 2. Meaning that our dy here can be substituted as a du over 2. Alright. Then now we can start to substitute. The 3 is still coefficient. We just copy down. And integrate integral symbol we need to copy down. 1 minus 2y will be substituted as a u, and the -4 copy down. Dy are going to substitute as a du, and over 2 I bring outside. Okay, over 2 here I bring it outside as a coefficient. Alright, then now we can start to integrate. 3 over 2, copy down, and integrate the u power of negative 4. You're going to increase the power by 1. You get a negative 3, and divide by negative 3. And because this is indefinite integral, you need to plus constant c. Then after that, we simplify our answer. I cancel off the 3, and then later on, the u can be replaced back by the 1 plus 2y. So I have a 1 plus 2y, power of negative 3 over negative 2. Don't forget a negative over here, plus constant c. And this can be still further simplified. I have a negative can bring outside. 2 multiplied by 1 plus 2y, power of 3, plus the constant c. Proceed to the example C. Again, we do the same thing. We will assume that the u will be 2 over 3x minus 5. And now we're going to substitute the ds in terms of du, meaning that we need to find the du ds as well. So du ds equals to 2 over 3. And now we know that the dx later on are going to be substituted as a 3 over 2 du. Alright, then now I can start to substitute. I have my u power of 4, and the ds are going to be substituted as a 3 over 2 du, and the 3 over 2 I bring it outside because it can be our coefficient. Alright, so the 3 over 2, just write it down, and the u power of 4, you integrate with respect to u, you have a u power of 5 over 5 plus a constant c. And the u later on we're going to substitute back with the 2 over 3x minus 5. I have my 3 over 10, and the u power of 5 going to be 2 over 3x minus 5 power of 5 plus a constant c. That's it. Example D, you have a t minus 4 power of 2 over 3. 2 over 3 is a power of fraction, is in fraction. I'm not going to expand and integrate. Again, I will assume my u equals to t minus 4. Get your du dt equals to 1, meaning that this is simple. Your dt later on will be substituted as a du. Now we start to substitute everything. The t minus 4 going to be u, and the power, just copy it down. Dt going to be du, just like that. Alright, then after that, I'm going to integrate this u power of 2 over 3 with respect to u. I have my u, and then the power of 2 over 3 increased by 1, meaning that you plus 3 over 3, you get a 5 over 3, and divided by 5 over 3, plus constant c. So bring the 3 up, you have a 3u power of 5 over 3 over 5. Now the u will be replaced back by the t minus 4. So you have a t minus 4 power of 5 over 3 over 3 plus c. For the question 7, you can see that the integration of the function itself, it is a linear, and it has a power of maybe the power more than 2. For example, 3, 4, 5, 6, 7, or the power might be in a negative form, negative number, negative integer, or might be in a fraction. Okay, but the inside the bracket is a linear function, and if we want to integrate this type of function, we just use substitution. Let u, assume the u equals to the function, the linear function inside the bracket, and we keep using the same approach to integrate by substitution. So now we proceed to the question 8, slightly different, but still we are going to use substitution. You can see that inside the bracket, which the function have a high power, is a quadratic function, and outside the bracket we have a linear function. For this type of function, we also use a substitution to integrate. Then if we want to use substitution method, we have to assume the u equals to the function inside the bracket, which is for this example, we're going to let u, assume the u equals to 2x squared plus 3. And here already given that given the tips to you, given the guide asking us to substitute the u as 2x squared plus 3. If this is not given, supposedly we must know how we have to assume the u equals to 2x squared plus 3. Now we look at the question A. Let's see how I'm going to integrate this function by substitution. To integrate this function, we're going to assume u equals to 2x squared plus 3. Just inspect the function, and if let's say that function having the high power, we're going to let u equals to that function. That is my quadratic function, 2x squared plus 3. And later on, I'm going to substitute this dx in terms of du. So I need the du dx here. Du dx equals to 4x. Here I have my 4x, which, x combine dx, bring up the dx, will be replaced by the du over 4. Why I need this x dx? Because what I can see here, I have my x, I have my dx. To substitute this x in terms of u, I have to join this x and the dx, and both of them later on will be substituted as a du over 4. Alright, and now we can see that x dx later on will be replaced by the u over 4, and the 2x squared plus 3 replaced by the u, and now everything in terms of u, we can start to replace it, to substitute now. We have a u power of 10, and then dx going to be x dx going to be replaced by du over 4. I have my du over 4, I bring out, now become the coefficient. Then to integrate this function becomes so much easy to integrate. I integrate u power of 10 with respect to u. I got my u power of 11 over 11. Because of indefinite integral, we need to plus a constant c. Simplify it, and you need to replace back the u as a 2x squared plus 3. And here, down here, I have got my 44 by taking this 4 multiplied by 11 plus constant c. This is the final answer. For this question, I will rewrite the question so that you can see that which the u need to be equate to which function. So now I'm going to rewrite this in this form: x multiplied by x squared plus 5, power of negative 3, integrate with respect to x. So you can see that here inside the bracket, still we have a quadratic similar to the example A. Alright, I have a quadratic, and outside I have a linear function. So this type of function, we're going to use, we're going to integrate it by substitution. Just let u equals to a function inside the bracket, because inside the bracket meaning that the power of this bracket is either is a high power integer positive, okay, maybe it's a power of 4, power of 5, which is unable to expand, and or you may have a negative integer just like this, or you may have a fraction number. Okay, so if you have this type of problem, you may think of a substitution. Alright, so now we let the u equals to the x squared plus 5. You can see that once I let the u equals to x squared plus 5, this becomes a single term, one term inside this bracket. So it's easy for us to expand. If you want to expand, you want to integrate, it's also much more easier. Alright, and then dx also need to be in terms of du, so I need the du dx. Du dx equals to 2x. So meaning that later on, I can see that this x and the dx, both of them joined together, it can be substituted as du over 2. Can you see? I bring this up, I got my x dx, bring the 2 down, I have du over 2. Meaning that the x dx here, later on, will be replaced by the du over 2. So we can see that now the whole function in terms of x originally, now we are going to replace it in terms of u. You can see that x dx is going to be du over 2. So over 2, I'm going to write it down here, okay, which will become the coefficient. And x squared plus 5 is going to be a u, and the power of negative 3, just copy down. Now, this function becomes so much easy to integrate. We have a 1 over 2 coefficient, copy down. Integrate u power of negative 3 with respect to u. You have a u power of negative 2. Just by increase this negative 3 by 1, you have negative 2, and divided by negative 2, and plus constant c. Then after that, we simplify. I have a 2 multiplied by 2, I got 4. 4, and then u need to be replaced back by x squared plus 5, power of 2, plus a constant c. Example C, you need to decide which you need to, this is by substitution. If you can see that this inside the bracket you have a cubic function, and outside the bracket you have quadratic. This type of function, yes, also using the integrate by substitution. As long as this the function outside is a 1 degree less than the degree insert in the bracket. All right. So now I will rewrite this function so that you can see clearer. I have my 3v cubed plus 7, and the power is 1 over 3. So you can see the power is in fraction. It gives us hint that this one cannot be unable to expand and integrate. So we need to use substitution method to assume the u equals to 3v cubed plus 7. Once we have find the du dv, we got something v squared. So this v squared, yes, it has chance to replace it with the in terms of a u. All right. So we get the du dv first. You can see that this is a 9v squared, meaning that later on the v squared combined with the dv, you can see that the v squared, I bring up the dv, and the 9 I bring to the other side. I have this v squared dv equals to du over 9, meaning that later on this v squared combined with the dv can be substituted as the du over 9. So now we have planned everything, and we can be sure that everything can be substituted in terms of u. We can start to substitute now. All right, you have your v squared combined with the dv, substitute as a du over 9. Again, the over 9 I will bring out, factor it out as the coefficient. And the 3v cubed plus 7 is going to be a u. Power, we just followed it back, is a 1 over 3. So now this function becomes so easy to integrate. I have 1 over 9, copy down, integrate the u power of 1 over 3 with respect to u. You just increase the power by 1, which you added by the 3 over 3, you got 4 over 3. And this has to be divided by 4 over 3. Because of indefinite integral, we plus constant c. And everything can be simplified. Now you have to integrate everything. So integrate, you need to simplify it. You got 3. U is going to be replaced back with the 3v cubed plus 7. The power is 4 over 3. Divided by 9 multiplied by 4, which is 36. Later on, the 3 and 36, it can be simplified further by just cancelling these 3 and 36. Simplified it. You got 1, 3, 3, and 12, 3. 12 multiplied by 3, you got 36. Then we simplify. We simplified it. We have a 3b cubed plus 7. Power of 4 over 3 divided by 12 and plus constant c. This is my final answer. Example D, we have this function. So now you can decide. You need to use assume the u equals to which function. You can rewrite the function in this form. And because of the square root is down here, we bring up. We have a negative 1 over 2. So from this function, from this form, you can see that the u has to be equals to something which is inside the bracket, and it has the power of either is a high integer, big integer number, or negative integer, or fraction number. So you now it's a tips for you. You need to let u equals to x squared minus 3. So other than that, we need to replace the dx in terms of du as well. You need to get the du dx. You got a 2x. So here you got the x, right? You can see that the x here inside my function, I also got an x here, and this x combined with the dx, it can be substituted as a du over 2. Let me show you. X, I bring up the dx, and 2 I bring down, meaning that x dx, it can be replaced by the du over 2. And the phi is okay because the phi is a coefficient. You just can factor it out. You can factor the 5 out and integrate. X dx can be substituted as a du over 2. Again, the over 2 I bring out. That will be 5 over 2 outside. And here, x squared minus 3 will be replaced by the u, and the power, just copy it down. So overall, we have this. All has already replaced by u. Then now we can start to integrate. Integrate u power of negative 1 over 2 with respect to u. You have a u, power increased by 1, you have power of 1 over 2, and divided by 1 over 2, plus a constant c. Then the 2 I can bring up, I got my 10, u power of 1 over 2, and down there I have a 2, alright, and plus a constant c. So you can see that the 10 and the 2 can be simplified into 5. 10 over 2 is 5. And this u has to be replaced back with the x squared minus 3. I have 5, x squared minus 3, and power of 1 over 2, plus constant c. You always can write this power of 1 over 2 as a square root. It's okay. If you want to stay with the power of 1 over 2, is okay. Alright. This question a little bit special. I have a 1 over square root of x outside, and 1 plus the square root of x inside the bracket. The bracket having the high power, which is a 3, and we're going to integrate this with respect to x. So again, you are going to assume the u equals to 1 plus square root of x. Then you get your du dx automatically. Later on, you will see this. Get your du dx first. You will have integrate this. You have 1 over 2. Bring the power of 1 over 2 down to the front, and you have a power minus 1. You got negative 1 over 2. All right. Then you simplify it. You will have a 2 square root of x. So you can see now appear the 1 over square root of x over here, meaning that later on your dx here combined with the 1 over square root of x. See that 1 over square root of x. Bring this dx up to the other side, and the 2 bring to the other side. You got 2 du. All right, meaning that the 1 over square root of x combined with the dx later on is going to replace by the 2 du according to here. Okay, then 1 plus square root of x will be replaced by 1 plus square root of x. Okay, 1 plus square root of x will be replaced by the u. Okay, then now we can start to substitute. Then this 1 over square root of x dx going to be du. 2 du 2 I take out. I got 2 here. And 1 plus square root of x is going to replace by u. I got my u. And power of 3, write it down here. And now I have to integrate u cubed with respect to u, meaning that I have a u power of 4, just increase the power by 1, and divided by 4, plus constant c. Then later on, we're going to simplify this. Get 1 here and 2 here. And the u, we need to replace back by 1 plus square root of x. We have a 1 plus square root of x power of 4, and divided by 2, plus a constant c. For the question 9, I have 6 examples, and both are all using this substitution. So the instruction is integrate the following by using the appropriate substitution, meaning that now is the question won't tell you you have to assume the u equals to which function inside our function. So we need to decide by ourselves. So as my tips, my hint to you is always assume the u as the function inside the bracket where that bracket containing the power, which is a high integer number or fraction number or negative integer. So for the question A, I hope that everyone can see that now we need to let u equals to which function in our integration. Okay, so here you can see that you can inspect this function. X cubed plus 5 having the power of 5, which is unable to expand. We are not going to expand it because it's quite complicated when we expand power of 5. So here I will decided to use substitution, let u equals to x cubed plus 1. If I let u equals to x cubed plus 1, meaning that later on, this will be substituted as a u. But what's going to do with the dx and the x squared? So we need to get the du dx. When you get the du dx, you get a 3x squared. So here you can see that you have an x squared here, you can have a dx, meaning that the x squared dx here can be substituted as a du over 3. Or here, very fortunately, I have a 3 over here, meaning that the 3x squared dx later on can be substituted as a du. You can see, I bring the dx up here. I can have my 3x squared dx equals to du. So meaning that these 3x squared dx, they join together and will be going to be replaced by du. So now you can see that everything done. We have successfully substitute everything, okay, in terms of u. You can start to write it down now. 3x squared dx, you have to replace by du, and the x cubed plus 1 going to be replaced by u. The power of 5 just remain as power of 5. You can compare both functions. After substitution, you can see that this function is so much easy to integrate. Integrate u power of 5 with respect to u, you get u power of 6 and over 6 plus a constant c. Now we need to replace back the u as a x cubed plus 1 over 6 plus c. So this is your answer. And for this question, the same thing, the same approach we will apply. You can see that the bracket here, x cubed minus 3x squared plus 1 power of 5. If I ask you to expand this cubic power of 5, you will be going to faint. Alright, and then now we can see that outside the bracket, we have x squared minus 2x. X squared minus 2x is a function, this is 1 degree less than the degree inside the bracket. So probably we can let our u to be x cubed minus 3x squared plus 1. Because when you get the du dx, you will get something in terms of x squared, right? So here you have the x squared minus 2x. It has a chance later on to substitute in terms of the to join with the dx, substitute in terms of du. To get your du dx, and then you get 3x squared minus 6x. Alright? And to substitute this x squared minus 2x, this is not exactly the same yet. But when you factor out the 3, you can see there is a x squared minus 2x, exactly the same as this. So now I can say that my x squared minus 2x, bring up the dx, I have my dx. This 3 I bring to the other side, I have du over 3. So clearly, you can see that the x squared minus 2x join with the dx here, both of them, can be replaced by du over 3. Look, this one, x squared minus 2x joined with the dx, will be replaced by du over 3. So here, I start to substitute. X squared minus 2x dx, substitute as a du over 3. Over 3, again, I bring out. Let it become the coefficient. And this one is going to be replaced by the u. X cubed minus 3x squared plus 5 will be the u, and power of 5 just copy them. So you can integrate very easily now. 1 over 3, just copy it down. And integrate u power of 5 with respect to u, you have a u power of 6 over 6 plus c. And later on, the u need to be replaced back with the x cubed minus 3x squared plus 1. Power, just copy it down. And here 3 multiplied by 6 can be simplified to be 18 plus c. For this question, you can write them in this form: x 1 minus x squared. What is the power of this square root? You bring up, you get negative 1 over 2, and going to integrate with respect to x. Again, I hope that you can see that the u can be 1 minus x squared. Again, I will inspect this function by just finding something inside the bracket, and that bracket having the fraction power or negative integer or the high integer number. Okay, so here for this question, we let u equals to 1 minus x squared. Get your du dx. You got a negative 2x. Now, you have an x over here, right? So you can see that x, bring up this dx, you have x dx, meaning that the x dx here can be substituted as a du over negative 2. Bring the negative 2 to the other side, you have this. Alright, so this x combined with the dx, later on, I'm going to replace it by the du over negative 2. Okay, so now everything's settled, you can start to integrate. You can start to substitute first, yeah? Substitute this 1 minus x squared, okay, as a u, and the power, just copy it down. This x dx join together, substitute as a du over negative 2. Again, the over negative 2, I bring it outside. I got my negative 1 over 2. Now, start to integrate. When you won't see any x, you can start to integrate. Okay, so this one, you get a u, power of negative 1 over 2 plus 1, you have a 1 over 2, and divided by 1 over 2. Plus a constant c. Bring these 2 up and cancel off with the 2 down here. You have a 1. So after that, you have u, substitute back with the 1 minus x squared, power of 1 over 2 plus a constant c. Okay, you can see that the 2 later on I bring up and you cancel off 2 down here. You get negative 1, yeah? You get negative 1. Or you may write your answer in this form: negative square root of 1 minus x squared plus c. That's it. For this question, example D, you might see that there's the function is containing the a. So you can predict that your final answer might be in terms of a. Yeah? Alright, we rewrite our question in this form. Then you can see that something inside the bracket having the fraction power, you can assume this as your u. Alright, let this become the u, a squared minus x squared. And later on, going to integrate it so that later on the dx here can be substituted in terms of u. Get your du dx. You have your, this one, a is a constant, a squared is a constant. So in differentiate, you got 0. So here you have in differentiate negative x squared, you got negative 2x. So you can see that the x, I leave it here to one side, and the x bring to the same side. Negative 2 bring to the other side. I have this. So it gives me the idea that the x dx here joined together later on will be substituted as a du over negative 2. Okay, then the a squared minus x squared, of course, will be substituted as a u, and everything already in terms of u, we can start to write it down. Alright, a squared minus x squared will be u, power of 1 over 2, and x dx going to be du over negative 2. Again, the negative 2 I'll bring outside, then become a negative 1 over 2. Now integrate this, just copy down the coefficient. Integrate the u power of 1 over 2, you have a u power of 3 over 2, divided by 3 over 2 plus constant c. Alright, so now I bring up the 2, let you see how do I simplify it. You have 6 down here. Then 2 and 6 can be simplified into 3. This is 1. Okay, and the u need to be replaced back by the a squared minus x squared. I have a squared minus x squared, power of 3 over 2 over 3, plus 3, plus c. That's the final answer. Example E, I have rewrite my question in this form. Because the square root of x squared plus 25, I bring up, I have my power of negative 1 over 2. Again, I hope that you can see which one is suitable to be the u. We're going to make these two terms become one term, which I will let u to represent it. U represent the x squared plus 25. And get your du dx. Next step, get your du dx. You got 2x. Meaning that x dx later on will be substituted as a du over 2. And you might be curious, I have x cubed over here. X cubed, you can actually write it down as a x multiplied by x squared. Okay, it consists of x multiplied by x squared. So the x, I will write it x squared multiplied by x. Alright, x cubed consists of x squared multiplied by x, meaning that 1x combined join with the dx later on. This will be replaced by the du over 2. Alright, then the x squared plus 25 is going to be replaced by the u. And how about this x squared? How to replace this x squared in terms of u? I can find it from here. Because we have assumed that the u equals to x squared plus 25, right? Then of course, x squared, it can be equals to u minus 25. Just bring this over to the other side, you can see that the x squared equals to u minus 25. Meaning that this x squared will be replaced by u minus 25 later on. So now you have seen that everything, it can be replaced by, in terms of u, you can start to write it down. Okay, the x squared is replaced by u minus 25. And the x, one of the x joined with the dx here will be replaced by du over 2. So over 2 again, I bring out the 1 over 2 so that it becomes the coefficient. And this one is a u power of negative 1 over 2. So now everything already in terms of u, we can start to integrate. Before we integrate, we look at this. Oh, this one can be expanded easily. U multiplied by u power of negative 1 over 2, and later on minus 25 multiplied by u power of negative 1 over 2. We have to replace it, we have to expand first before we integrate. Okay, then you can expand by multiply this u by the u power of negative 1 over 2, meaning that the power can be add up. Originally this is a power of 1, add with the power of negative 1 over 2, you have power of 1 over 2, minus 25 multiplied by u power of negative 1 over 2, just copy down. Okay, that will be 25u power of negative 1 over 2. Then now we're going to integrate this with respect to u. We integrate term by term. Once we start integrate, there is no more sign of integral. Integrate with u power of 1 over 2, you add, increase the power by 1, you got 3 over 2 over 3 over 2. Minus 25, copied it down, u plus 1, you have a power of 1 over 2 over 1 over 2. And plus the constant c. Now you have done the integration, you just need to simplify and substitute the u back with the x. This will be 1 over 2, 2 bring up, and u replaced back by the x squared plus 25. You have x squared plus 25, power of 3 over 2 over 3. Minus, and the 2 bring up, multiply by 25, you have 50. U going to replace by x squared plus 25, and power is a 1 over 2 plus a constant c. Alright, then everything can be multiplied by 1 over 2 here. You have for this first term, the 2 can be cancelled off. So you have x squared plus 25, power of 3 over 2 over 3. And the second term multiplied by 1 over 2, you have 25. Square root of x squared plus 25. And don't worry, the c, maybe you can say that the c divided by 2, you will write c over 2, or we don't have to care this so much. We just replace it by a bigger c, maybe the bigger c representing the c over 2. So this is okay to write any constant, any symbol to represent the constant. That is the answer. For the example F, I'm going to rewrite this question in this form. That will be a 4u plus 1 multiplied by 2u squared plus u minus 3. And this is going to be power of negative 1 over 2. We're going to integrate this with respect to u. Again, since this is in the symbol of u, the variable, or the variable in terms of u, so we're going to replace it by another symbol. Let's see, we can use k. All right, let the k equals to maybe okay, this is 2u squared plus u minus 3, because I'm going to substitute this by a single term, which is replaced by the k, because this is in a bracket and it has the fraction, power of the fraction. I'll let the k equals to this. Later on, this will be substituted as a k. Later on, the du also need to be replaced by in terms of dk. So I need to get a dk du. dk du equals to 4u plus 1. Okay, so here I can see 4u plus 1, you see or not? 4u plus 1 join with the du over here. Both of them join together later on can be substituted as a dk. See or not? I bring the du up here. And the dk is in the other side. So it means that du plus 1 join with the du will be substituted as the dk. And now everything settled. We know that everything or can be substituted in terms of du. Then we can start to write out. This one can be replaced by dk. And this is your k with the power of negative 1 over 2. So here, we need to integrate k power of negative 1 over 2 with respect to k. Just increase the power by 1. You have a k power of 1 over 2 divided by 1 over 2 plus a constant c. And we're not going to leave our answer in terms of k. The k need to be replaced back by the 2u squared plus u minus 3 power of 1 over 2. And the 2 bring up plus constant c, or you may write your answer in this form. Change the power of 1 over 2 to the square root. You have a square root of 2u squared plus u minus 3 plus constant c. Come to the question 10, which is my last question in this video. Here I have a function of this, and you can see that the power 1 over 3 is on the x power of 4 plus 1. So we know that the substitution has to be let maybe u to be x power of 4 plus 1. All right, here is a question giving you the hint that we need to use the symbol v. All right, v represent the x power of 4 plus 1. We just use back the same symbol as given. Just write down the question first. Copy down the question. And I'm going to not let, because this is given. So the v equals to x power of x power of 4 plus 1. We need to get the dv dx later on, so that the dx can be substituted in terms of dv. We have a 4x power of 3. So here I have an x power of 3 dx will be replaced by the dv over 4. Here I have got x power of 7. Do you see that? I have x power of 7. So x power of 7 is consists of x power of 4. Okay, x power of 3 multiplied by x power of 4. Okay, so x power of 7, it can be written as x power of 4 multiplied by x power of 3. Then this x power of 3 joined with the dx can be substituted as the dv over 4. All right, this can be replaced by the dv over 4. dv over 4. dv over 4, sorry. And this x power of 4 plus 1 will be replaced by v later on. Then what happened to the x power of 4 here? X power of 4 here, of course, you can see from this statement. v equals to x power of 4 plus 1, meaning that x power of 4 can be written as b minus 1. This will be b minus 1. According to this statement, v equals to x power of 4 plus 1, meaning that x power of 4, it can be written as v minus 1. So I can see that the x power of 4 later on can be substituted as a v minus 1. So everything we have planned, okay, we're able to substitute everything in terms of v, and now we can start to write it out. Integrate. This one will be v. X power of 4 plus 1 will be replaced by v, and power just copy down. X power of 7, we have a split it into the x power of 4, x power of 3. X power of 3, dx will be substituted as a dv over 4. So just write down dv. Over 4 just bring out. It can be our coefficient 1 over 4. And the x power of 4 here, later on, now we can replace it by v minus 1. So we have done it. Everything already successfully in terms of v. There is no more x in our function anymore. We can start to find ways to integrate. To integrate this function, I suggest to expand it first. Expand v power of 1 over 3 and v, which is a multiply, you get v power of 4 over 3, where the power of 1 add with the power of 1 over 3, you got 4 over 3. And v power of 1 over 3 minus multiplied by negative 1, you get negative v power of 1 over 3 dv. So now integrate, just integrate. Integrate this v power of 4 over 3, you increase the power by 1, meaning that you add the 3 over 3, you get v power of 7 over 3, and don't forget to divide by 7 over 3. Minus the second term, you integrate, you plus the, increase the power by 1, you plus with the 1, you have 4 over 3, and divided by 4 over 3. And don't forget to plus a constant c. And now I will bring this up. The 3 bring up, you have a 3v power of 7 over 3 over 7, minus the 3 bring up, you have a 3v power of 4 over 3 over 4, plus c. The final answer, you should give your answer, the 1 over 4 you can multiply in, and the v need to be replaced back by x power of 4 plus 1. So I have 3. The v replaced back by the x power of 4 plus 1, power of 7 over 3, and 4 multiplied by 7, 28, minus, alright, and this for the second term, you have 3, v will be x power of 4 plus 1, power of 4 over 3, and the 4 multiplied by 4, you got 16, plus constants. Okay, thank you for watching.